Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan bin Muhammad Farid Uzaidi. My ID number is CE180156. So today I'm going to present my FYP2. So my title for my FYP is Lightning Impact on the Transmission Line and its Mitigation using MATLAB Simulink. So my supervisor for this project is Prof. Madya Dr. Dur Muhammad Somro. So I'm going to straight to the introduction of this project. Transmission line is very tall and very large space of area, so it's open to possibility to be struck by lightning. Next, TNB or Tenaga Nasional Berhad has claimed that around 50% of total failure are caused by lightning strikes. Next, lightning strike can cause flashover in the transmission line when it directly hit to the transmission line. When lightning strike the ground or the object near the transmission line, it causes induced voltage in the power line. So next is the problem statement. So this lightning effect on the transmission line can cause impulsive transient in the substation with subsequent damage and cause blackout to the certain area. To intercept this phenomenon from happening, we can install metal oxide surge arrestor on the transmission line. MOSA, known as metal oxide surge arrestor, is a arrestor that can mitigate impulsive transient that occur on the transmission line. MOSA was chosen because it can handle up to 450 kV. MOSA does not absorb all the voltage that pass through it, it simply diverts it into the ground. The voltage, this can avoid impulsive transient from happening. Next, all of this will simulate in the MATLAB Simulink software. Next is the objective. The objective, first objective, to investigate the power quality problem of impulsive transient that occur when the transmission line is struck by lightning. Next is to design MOSA, and third is to mitigate the impulsive transient effect on the transmission line that caused by lightning by using MOSA in MATLAB Simulink software. Next is scope. This project focuses on overhead transmission line when it's struck by lightning. And next is the PQ problem is impulsive transient. Next is design MOSA. And next, the simulation will be carried out by using MATLAB Simulink software. And the rating for the transmission line is 270 kV and 200 kilometer distance. Next, I will show the methodology for this project. So this project have two phases. Phase 1 is FYP1, phase 2 is FYP2. So during my phase 1, I identify the power quality problem related to lightning impact to the transmission line. And then after that, I identify tools and technique to mitigate the power quality problem. And after that, I use MATLAB to design a transmission line system, or I call it a test case. And after that, I use MATLAB Simulink also to create fault test case, which is there will be a lightning strike to the transmission line. So next, the phase 2. Phase 2, the first test case designed to mitigate the lightning effect. And the last test case is modeled to investigate the behavior of the MOSA inside the transmission line when there is no fault. Okay, next, all the project use software simulation. The software is MATLAB Simulink to model a circuit for the transmission line before and after it struck by lightning. Next, simulate the mitigate method on the circuit model of transmission line when it hit by the lightning. So first I will show the steady state case condition. So this is the transmission line circuit model or system. So there is supply of 275 kilovolt and a distance for 200 kilometer line and a load of 1000 megawatt. So next is the transient test case condition. So it's a bit identical to the steady state, but right now the transient test case inject a lightning current into the system. The lightning current used as a current source block from the MATLAB. So the value of the current around 30 kilo amp. So next is the mitigation test case condition. So as you can see, there is slight difference. This is because there's MOSA connected parallelly to the ground on the system. So the MOSA is around have 20 columns of such resistor. So next is the transparent test case condition. This one is quite similar to the mitigation test case, but there is no fault inserted in this system. So next, I will continue to result. All the test cases were simulated in MATLAB Simulink software. The time had been set from 0 second to 0.4 second as a constant time interval. The source of the system is 250 kilovolt and 200 kilometer length of the transmission line. The waveform was collected at the system output by using scope block in the MATLAB. So this is the waveform output for steady state case condition. So all in the waveform in sinusoidal form. So the value are quite constant because there is no fault inserted. So next is a transient state case response. So this is a waveform after a transmission line struck by lightning. The lightning will strike after 0.1 second. So as you can see, the system possibly blackout. So next is the mitigation state case response. So as you can see, before 0.1, the fault is on. So the voltage are quite high. But after 0.1, the voltage sinusoidally constant. Also same as the current. So finally, the transparent state case response. So the waveform are quite similar to steady state because there is no fault inserted, but the value are quite lower than the steady state because in the simulation the MOSA act as a load. So I'm going to straight for the conclusion. In conclusion, all the objectives were successfully achieved. First, identify the power quality related to the lightning effect on the transmission line. Impulsive transient is the most happening during lightning. After that, the test case steady state circuit of the transmission line system is designed and used in this project. The transmission line carries 275 kilovolt with 200 kilometer distance. For the test case condition, the lightning injected around 30 kA to the steady state condition of the transmission line system. Lastly, the test case mitigation technique used is MOV based. The MOSA is connected parallelly to the ground and to the ground load. The MOSA can discharge over voltage to the ground. As a result of this project, the MOSA can mitigate impulsive transient. So finally, the recommendation for future for recommendation, use different type of power quality problem that occur inside the transmission line. Use different types of software to simulate this system, such as PS card. Use different types of mitigation technique, and finally varies the parameters of the system. I think that's all for me. Thank you.